Opportunities are that emerge from those problems, right? That's not just marketing. Problems are opportunities in disguise. And talk a little bit about some of the approaches to making the cloud be what we need it to be, what we want it to be, to bring on that application adoption, particularly in the enterprise space, right? It's all about the enterprise at the end of the day. That's where the biggest set of applications live. That's where the large bulk of the work that will be done in the future will continue to be done as it is today and has been done in the past for some time now. But we have to be careful not to lose sight of application developers, application development space, and some of the interesting work and new patterns that will emerge. I mean, Danny's conversation was spot on. Platform as a service is interesting. It's been interesting for 10 years. It will continue to be interesting 10 years in the future. So let's get into it. So what are clouds? There are many, many clouds. Everyone has taken, or a lot of folks have taken a shot at defining the cloud, defining a platform. Cloud is a platform. Platforms are applications. Each of these clouds present a REST-style API of some sort for control. Control and observability of the resources that it's meeting out and doling out to requesting applications. It's a triad, as I always describe it, of compute, network, and storage. Various physical resources that have been virtualized and doing work on behalf of people. It's the people part that people often forget, cloud builders such as ourselves often forget from the point of view of this is, we're doing work on behalf of. What do these things enable and how do they enable it? Well, first off, they enable pretty much any style of application. Folks don't believe that generally today. They're not entirely sure that's true. I believe it's true. It's a general purpose computing platform. We can do many, many interesting things with the right approach from a technology point of view if we tackle the hard problems. All right? We got to go after the hard problems. That's where the opportunity is. It's virtualized. Why virtualized? Is it strictly speaking necessary? Not really. But from the point of view of utilization, from the point of view of the economics of cloud, the point of view of the economics enabling the cloud model, the utility computing model, absolutely required to virtualize. As I've said in the past, Adam Smith, shout out for a Scottish philosopher, Adam Smith has a lot more to do with computer architecture than Gordon Moore, right? Because it is really all about economics, and it's been this way for the longest time. Mainframes to minis, minis to micros, workstations, and those into PCs, and now tablets. The utilization, the ubiquity of these endpoints, the ubiquity of the scale, right? But with virtualization, we've lost some things. While we've gained a lot, we've also lost some things. We lost control of the physical platform. We lost control of our ability to actually program to the metal and gain the benefits directly of the metal. It's not just performance. It's performance and determinism, right? Not just raw speed, but also reliable, consistent speed. So what are clouds? Because of the utilization, because of the utility model, they have to be multi-tenant. That's the utilization side. That drives the economics of the model. But on the other hand, it also drives the noisy neighbor problems. It drives the tough engineering problems that we all get to face when we're back at the ranch, right, back at the shop. So the multi-tenant nature of the cloud forces us, the cloud builder, to take on new demands to try and provide the application model, the runtime environment model that makes the application delivery consistent, reliable, necessary for the enterprise marketplace. Each of these cloud models, each of these cloud providers have a diverse, rich set, that's the positive way of phrasing it, of APIs, right? Every cloud platform that's come out has emerged with a different model for application developers to latch onto and to program to. I kind of reject that notion. I'm not an either or. It's OpenStack or it's AWS. It's CloudStack or it's OpenStack. I'm an and guy, right? It's OpenStack and CloudStack and AWS. Those are just signatures. Those are service endpoints. Yes, they embody an infrastructure and an implementation underneath that, but you can abstract that in your object models underneath. So there are different controls in the cloud space today. It shouldn't be an or. It needs to be an and. What are enterprise applications? It's a potpourri of opportunities for different runtime models, different infrastructural models, different middleware models, different identity, authentication, billing, selling, on and on and on. There are many, many different types of applications, but this is where the gold is, folks, right? There's a $1 trillion market in front of us, and cloud is still very nascent, right? We've, a lot of folks in this room watching this conference grow over the years. A lot of folks in the room now, and we're all cloud technocrati, right? We know what we're talking about. We know what the cloud is all about, what it's capable of. We're still just in the very baby steps of where we're going now. To be able to deliver true, compelling platform for the marketplace for today and in the future that meets the challenges of performance determinism, security, auditability, compliance, log structures, application uptime, platform runtime, all of these aspects really is what the challenge is all about for all of us. It's the hard stuff, right? So what's so difficult about it? Why is it hard? I mean, it does loads in stores, you install it, you boot it, it runs, does reads and writes. Why is it hard? No, first off, it's hard because of security. Right? The application or enterprise data center ready, deployed security model demands that there be very tight controls in the enterprise, that you have strong authentication, not only in login and access to the applications themselves, but also strong security models and access to the runtime environment. Can you upgrade it? Can Bob log in and grab the logs off the thing? Can Sally upgrade the latest patch for the OS version? And lastly, how are you providing access to the application for your end users over the internet, within your intranet? How do you know that the right things are happening? Are you making a strong authentication and authorization model to provide access, and so you know who has done what when? Dependency management, it's a nightmare. You look at, back in the old days, A.out, right? It depended on the C runtime library. Then you were right in the kernel. It was great. That was pretty simple. Nowadays, with the middleware stacks and the growth of various frameworks, the alphabet soup of software technologies that are out there now, you build this order n squared dependency map. The more layers in the stack that you build, the more complex the combinatorics gets, and the more difficult it is to provide reliable, dependable service day after day after day. That's what it's all about. And lastly, how do you manage this platform? How do you manage this application stack with those myriad dependencies, with those security constraints, and do it in a fashion that's both deterministic as well as performant? Okay, that's clouds of tomorrow. So let's talk a little bit about security, going a little deeper. It's not just about protecting servers, logins and lockdowns of ports, and put a firewall in front of it, and maybe have a VPN server where only you're logging the credentials of folks that are hitting it. It's also about protecting your networks into the data centers itself, and ensuring that the access to folks that are actually able to get in on a mobile workforce, an increasingly mobile workforce, are able to see the applications that they need and are doing so in a way that's relevant and safe for you, and meets your compliance burden, right? The Sarbanes-Oxley and other legislation that's come on board, not only in terms of the financial statements and in terms of managing your business, but also in terms of actually protecting your data, right? So are you doing right things from a key management point of view? Again, it's an identity problem as well as a data structure problem or a data problem. Are you doing things in terms of providing strong availability of the data? And are you doing things to ensure that not only your primary stores, but your backups and replicas are being managed in a way that meets your compliance burden? Driving on. So dependency management. That's a typical three-tiered application, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 tiers. So it's everything from the front end, the presentation layer, all the way down through the physical infrastructure, and all the pieces in between. Which piece do you update? Do you update the whole stack? Do you take downtime when you update that stack? What do you do about incompatibilities? Did you lose your data set? Did you lose your identity store? Right? So it's that kind of problem. and then overlaying those application stacks on your infrastructure. You have Gen 1, 2, 3 networks and versions of products that are interoperating, where your data center and your network management people have been doing heroics for years and years now to keep the trains rolling. And then you got to upload your latest, greatest software, and you're thinking to yourself, good God, how is this all going to work? So it's not only about the stacks and the complexities and the combinatorics of the management within the stack. Now you have to overlay it on the Z-plane, right, of the infrastructure itself. And the dependency problems grow worse. Management, managing the life cycle, the patch management, the updates, drivers, agents, third-party software that you don't control. Are you in lockstep with their delivery schedule? What happens if it breaks? What do you do? Can you roll backwards? Can't roll backwards. Right? We've all seen these things over and over again. And this grows with the spread of VM sprawl, right? This grows with the spread of VMs across the entirety of your data center. So now you have this myriad complex Rubik's Cube of things you're trying to tie together to deliver tone for your business, to keep your business rolling, to keep the service delivery going, keep the application delivery going across this entire scope. So these are the problem spaces that we have. And in performance, and this is a biggie, particularly a big problem right now in the cloud, in the multi-tenant cloud. And we got, what, 600 people or so in this room. We're 600 different unique credentials. We're all on the same common infrastructure. We are actually all competing for the same resources at the same time. How do you manage that as an infrastructure provider and deliver ubiquitous or deliver consistent performance and also fast performance, right, within the cloud itself? Again, the multi-tenant nature of clouds it's a wonderful thing for the economics of it. And it's a wonderful thing for some of the security aspects of it because it provides a nice isolation container. But it's in exact contrast and diametrically opposed to what you're trying to do with performance. So where's that blend point? Is it a blend point? Can you have both? So going forward, the clouds of tomorrow, right? Where are we going to be in 5 years, in 10 years? I personally believe that there's still a lot of golf to play in the infrastructure as a service arena. A lot of folks have said, well, that's done. OpenStack solves the problem. Throw 1U servers at it, and you're good to go. Right? I don't believe that's true. There's a lot of innovation in the areas of fabric-based computing, high-density servers that's going on. There's a lot of interest in storage and innovation that's still going on in the storage level with SSDs and some software-defined storage stacks, and of course in SDN, right? And that's why a lot of folks are here right now. So in the infrastructure arena itself, there's still an awful lot of things that can be done to provide more security, better performance guarantees, and concrete performance guarantees. If you got 1,000 IOs a second yesterday, you'll get 1,000 IOs a second today. That can be done. It can be done in the platform. Configurable networking. Layer 3 networks are great. IP addressing, it's a big deal, probably here to stay. But there are other things that we can do from the point of view of providing stretch networks across data centers, partnering with certain telcos that I might have to work for, to provide private IP connectivity from the data center back to the customer premise in a secure, performant manner, and building software overlays over those secure networks so that the customers can actually manage them in the way that they are accustomed to. Right? So I'll get into that in a little bit. And lastly, the ability to be flexible in that environment, to be elastic, to flex and condense as time dictates and as resource requirements dictate. So with multi-tenancy, right, isolation is key. I have 600 unique accounts, 600 unique identities, 600 unique organizations that are being represented by those identities. I have to make sure that as I build out my infrastructure, I'm not only driving my utilization factors and I'm creating that multi-tenant environment that's the most flexible and condensed to provide the best utilization for me to hold on to my cost structures and manage my cost structures, but also do so in a way that doesn't interfere with these performance guarantees and doesn't provide leaks, security breaks, and security detriment. So isolation is key. And so what folks have done in the past is build a dedicated infrastructure as a service platform. We believe that multi-tenant infrastructure as a service is where we want to go. And it's really a combination of providing the hypervisor, storage, and networking, the hypervisor representing the compute side of that triad, building those things together in the platform by using techniques such as software-defined networking or using storage architectures that are more protocol-based as opposed to pure SAN-based as a software entity, and being very flexible in our ability or in the infrastructure's ability to combine infrastructural components, whether they be networks, whether they be firewalls, whether they be routers, what have you, in a way that brings a virtualized representation of software entities as the infrastructural delivery element. And lastly, layering the application over on the top end of that. So performance guarantees. So today, applications are provided in the data center, right? They're provisioned in a data center. And there's a whole ecosystem, and there's a whole cultural element to, and a social element to how applications are managed within today's enterprise space. You have your database administrators and your storage area network administrators and your network administrators and your buying agents, and we all know this drill. We know who these people are, right? In the future, what we have to provide and where we're going is by providing a quality of service control, actual QoS for storage, network, and compute that's better than what you're getting in your isolated silo provisioned within the data center stack. So quality of service controls. Better, faster, more insightful ability to provision the infrastructure by supporting, as I mentioned before, not just OpenStack or CloudStack, but and. The ability to do and. The ability to run hypervisor images of one type versus another type. How about hypervisor images of all types, right? KVM, NXen, NVMware. It's possible to do this kind of technique, thereby making it easy to do that dependency management that I spoke about a while ago and get your application stacks up running faster and with less interference. Compute and storage control. So it's always size, right? Compute around the storage space. It's so many terabytes, so many gigabytes, what have you. But it's more than that. It's the ability to provide the notion of replication services. I mean, why do we force the application? One of the big inhibitors for application adoption within the cloud is, as cloud providers, we punt back to the application developer and say, reliability and availability is kind of your problem, right? I'm giving you cycle, storage, network, and the infrastructure to run all that on. But you figure out your replication and your disaster recovery strategy. I don't think that's necessarily what we have to do. So we can build compute and storage controls to build that into the platform that allows the application to prepare for disaster events, to build a high availability architecture using the primitives and the fundamentals within the infrastructure itself. And lastly, managing the performance, the deterministic performance from a virtual point of view, such that you don't have to go in and add more memory to your storage array or add faster disks to your storage array. You don't have to provision a 10 gigabit link between the application nodes themselves. You can manage all of these things as virtualized assets. Danny had talked about the fact that the operating environment is a software-defined network, software-defined storage, and a software-defined operating environment. I share that vision. I share that very much. The physical plant is the physical plant. The logical tier is where all of these constructs are abstracted and brought together as part of the orchestration layer to present back out to the application runtime environments. So the arbitrary restrictions of layer 3 can be lifted. There's no reason you can't program to the infrastructure, to the components of the infrastructure, to present a layer 2 or layer 3 network that supports multiple and arbitrary NICs, multiple and arbitrary VLAN sizes. You can get rid of the 11Q restriction of 4096. You can also have the ability, when you build networks as a user-defined networking construct, to build arbitrary subnets with arbitrary routing entities across these subnets. And you do this by building software appliances or presenting software appliances. The other neat thing about this is that, or this approach to building clouds, is that the model in which people have become familiar and comfortable for managing their networks. They're a Cisco shop, they're an F5 shop, they're a Juniper shop. All of these things run as virtual machines today. And you can deploy these as virtual machines by presenting that same common interface dependency that they have, abstracted, so they depend on layer 2, present a MAC address to them, right? Even though it's an abstraction, even though it's a virtualized representation of a MAC address on a layer 2 network. So you can still build the same dependency maps and resolve those same dependencies, just do it through virtualization techniques, much like the hypervisors did for the CPU memory and interrupt path. Ultimately, this leads to, as I said, user-defined networks, right? Put the control back in the hands of the users to build the network the way they want. So the innovation that needs to take place in this space is more than rack and stack of one-use servers. It really is a systems engineering and operating systems job to get back into the machines themselves and build out the cloud infrastructure to present and enable the cloud infrastructure the way that presents the most flexibility for the end customer to build their networks, to build their security perimeter, to build their performance controls the way they want. And once you have that kind of abstracted virtual environment, then the notion of general purpose computing does in fact come back to the cloud. And at that point, software environments can be defined the way any user wants to define them. You can bring your own business processes. You don't have to have a prescribed business process as dictated through the REST API of the cloud. You can bring your own tools, right? You don't have to use whatever tools are out there. I know there's a great marketplace of tools that are emerging in the cloud space right now, which is fantastic. But there's a lot of tools that are existing practice within the enterprise today. Those should be able to continue to run. OS templates, whether they be open source templates or industry standard and blessed templates from Windows, Red Hat, what have you, all of these things continue to run. The management practice and lastly the drivers continue to run through that operating environment in a platform or on a platform that has been abstracted to present everything as a software entity back up through to the cloud. And in doing it this way and in building a cloud with these sets of abstractions, what ends up happening is that the application's ability or the customer's ability to deploy their runtime stack can be done anywhere. It's independent of the choice of any of the cloud providers. When cloud providers, cloud builders such as myself, get to the point where they have abstracted out the notion of the particular physical hardware or have bound the customer to a unique set of APIs and presented that API as the sole implementation, have gone to more of an and model, then it becomes very easy and possible for customers to be more flexible, to be more location independent, and to be able to present their application runtimes in a multitude of environments. So my general theme in closing, before we hit some Q&As, is control and choice. Control of what to run, how to run it, whether it be managing your IOPS, whether it be managing your bandwidth, whether it be managing your identity space, right? You can federate identities using a technique like SAML. And the choice of where to run and how to run your application go back to the user. It's one of the hallmarks of our vision, Terremark Verizon's, or Verizon Terremark's vision of the cloud future, is that it's about choice. It's about embracing the ecosystems that are emerging, and it's about choice for the user to present the best possible environment for them in which to conduct their business in a cost-effective and secure manner. And that was all I had. Thank you.
Okay, so same procedure. Thank you so much, Kevin. If you can catch my eye, the house lights are up. Do we have any bold questions? Right there, an easy one. Mike 2.
What is the biggest security problem you see on the horizon, and what is being done to address it?
The biggest security problem on the horizon is being addressed through Verizon. I can take an opportunity to make a rhyme. So one of the biggest threat we actually have right now are distributed denial of service attacks. And some of the attack vectors that we're seeing on the network today, they're popping up in a myriad of places, whether they be in the financial institutes or in the government institutes, and certainly against the cloud providers themselves. That right now is our biggest challenge. When we start getting some conformity and more ubiquitous distribution and tying together some of these peering networks to run these packets through a cleaning house, we'll have better security perimeters over the front end of the data centers.
Any more from any more? You're up against the fact there are 9 sessions that you're about to rush out to. A final question or not? Because
right over here,
if
there's
not,
a woman right over yonder.
right over where?
Second
wave,
row.
Wave, wave. Ah.
Second row. She's waving frantically.
Thank you, sir.
My question is regarding isolation as a key that you talked about, multi-tenanted infrastructures. And I think the example you gave is of different organizations. And how, within organizations also, you need to protect data across divisions, across organizations. How simple or how complex is that? I mean, conceptually, it's very, we do understand that is something that we need to tackle. Mm-hmm. But how do you really do it as a real world? In a real world, how do organizations do it? And how is it being handled?
So it's a combination of technology by using virtual VLANing techniques in layer 2 to provide configurable networks the way the Uber administrator, somebody has to oversee the shop, right? The way the Uber administrator wants to partition the workloads and access to the various compartments or departments in this case. And the second part is overlaying a logical identity and roles space on top of those networks to whatever the assets are underneath, okay? It's technology and business process, right? And some of the mechanism for RBAC.
That's a great note to end on. They'll all be getting to their sessions a little bit early. They'll be thanking you. And as we are going to do. Thank you so much, Kevin. Let's give it up for him. The Verizon Horizon pun will be much appreciated.